Hello, everyone. Thank you for joining us today for our MLOps Handbook workshop, a guide for improving the effectiveness for ML practitioners. So we have David Tan today. We'll be beginning our session with a little bit of introduction and hand over the stage to David. So for those of you who are joining us for the first time, Women Who Code is a global nonprofit organization that helps women engineers with 2 or more years of work experience, looking for support and resources to strengthen their influence and level up in their careers. We stand with a vision to build a world where women are representative as technical executives, founders, VCs, board members, and software engineers. You should check out our events on Meetup. We have Interview Ready series and TensorFlow Study Jam, which are going on right now. And we have many more coming up. And you can see our past events on YouTube as well. You can join us as volunteers. Just log on to womenwhocode.com/Singapore and let us know if you're interested for any volunteering opportunities. It's a gender neutral community, so everyone is welcome. Without further ado, I'd like to introduce David. David is joining us from Melbourne. He enjoys helping clients succeed by applying enduring engineering practices, example, automated testing, CI/CD, and lean delivery practices. For example, vertical slicing, build, measure, learn. He also has written articles and conducted workshops on writing clean and evolvable code in machine learning. His article, Coding Habits for Data Scientists, which the link for this was shared on a Meetup group, on a Meetup event. This article was also shared widely in the data science community. David, would you like to take this event further?
Yep. Thanks so much, Tosha, for organizing, and thanks everyone for coming. And yep, so I understand it's probably dinner time, so feel free to leave your camera off, have your dinner, that's all right. I'll share my screen. Cool. So it's not a small group of us, so it's cozy, and we'll try to make it. I want to make it interactive in that I'm not just going to throw information at you. There will be question points. Yeah, to kind of understand what you want to learn about ML, MLOps, effective ML. What's that all about? So with that, a little bit introduction about myself that Tosha's already mentioned. So I'm an ML engineer at Thoughtworks. I am also writing an upcoming book with O'Reilly called Effective ML Teams, and a lot of the things that I talk about today will be featuring in the book. The thesis is that, or the main thing is that, we do a lot of ML in the world, it's scaling everywhere. Everybody wants to do ML. But at the same time, we have learned in the past few years, we've burnt our fingers in some ways, in terms of engineering, in terms of product, in terms of ethics, in terms of delivery. So what can we learn from that so that, we can not have to reinvent the wheel every time? So that's what the whole book is about. I'm a career changer, so I was not always a techie. So I actually had an arts background in NUS. And so, yeah, I think my first job was totally non-tech, and I looked at my economist colleagues who was writing, amazing econometrics models, and I was like, oh, this is so crazy. I could never do that. It looks so scary. And by chance, I got to join General Assembly, a 3-month coding bootcamp. That's when I learned how to code, and then I joined Thoughtworks, and I learned how to code some more, and just learn on the job, pair programming, learning from great folks around me. And yeah, eventually got into data and AI and find myself in the ML engineering space these days. And yeah, you can find me on Twitter or LinkedIn. That's here. I don't tweet much, but if you want to see updates about books and things like that, you can subscribe. So at this point, this is where you will be doing some work. So if I can trouble you to go to this link, I'll share it on chat. And I want to just ask you 4 questions, basically how much data science do you know or have you done? And so that I can just adjust the talk accordingly. If you're on your mobile phone, you can also scan this QR code. And yep, okay, I see people are already filling up the first question. So do you consider yourself as a data scientist, ML engineer, both or neither? I might as well just bring this screen up here. Side by side. So when we've got a fair number of respondents, we can go to the next question. Cool. Just out of curiosity, for folks that have said neither, if you want to come off mute or type in the chat what your role generally is. Is it product, or are you looking into coming to ML? Just out of curiosity for myself. Software engineer, fantastic. Oh yeah, I've totally neglected software engineer, which, yeah. DevOps, fantastic. Yeah, I think software engineer, application developer, DevOps are all kind of pretty good segues or paths into ML if you're interested. Like ML engineering is a lot about DevOps as well. So I hope what I shared today will be useful. Yeah, fantastic. So next question. How experienced do you consider yourself in ML? So have you done some Hello World, beginner, you have some more experience, even more experience, you're an expert, or none of the above, you've never done ML? And that's also okay. Okay, fantastic. So we've got a distribution there. Yeah, that's great. Thanks, Toshao, for this Slido app. It's really awesome. The next question is, are you using continuous delivery in practices in your ML projects? Yes, no, and what is continuous delivery? I will cover this in the talk, and I just want to know that I'm not telling you things you already know. Yeah, very nice. Very cool. Yeah, so we got a fair split there, 3 ways. And lastly, so today we'll have a hands-on demo session. For today's session, it will be mainly me coding and you watching, but in future session, if you are keen to continue, then we can flip it around and you will be coding. So would you like to learn more about test automation in ML projects? Would you like to learn about code editor tips, or would you like to learn about how to refactor, especially a Jupyter notebook? Okay, fantastic. So yeah, so I can focus on the right things in the demo. We'll probably touch on a bit of three, all three topics, but just how much depth I should go into. So thanks everyone. Thanks for being really participating. Cool. So I usually start this set of practices about effective ML by telling a story. And this is a story that you may have experienced for those who have done some fair bit of data science. So this, I call her Dana. Dana is a data scientist, and it's quite a common journey I've heard from several data scientists. First, you join an organization, whatever that may be. Usually you're in a data science team that is different from the application team. So application might be doing whatever, property guru or whatever you can think of, Food Panda, cool stuff like this, actually making revenue for the company. But data science is usually like this silo department somewhere else. And you are iterating and you're building proof of concepts. You may have to bribe a data engineer for, one-time backend dump of some data for you to do your analysis. But usually you're like, waiting. You're asking some data for offline analysis. So off in a silo. And then, we do what we're really good at, like proving ML proof of concept. So I called it the Kaggle zone. So this is what we are, as data scientists or ML practitioners, very confident in. Modeling, exploratory data analysis, prototyping. We're pretty good at that. And we may present something and proof of concept and show that, hey, ML can help you do whatever, predict aircraft engine failure, or predict your self-driving car, whatever that is. But then we want to say, the board is the management is convinced that ML is cool and awesome, and now we want to operationalize this thing, right? We want to put it out there. And typically what we see is this throw the code over the wall type of thing, which we will go into more detail. Somebody else has to so-called productionize this thing. And typically that's a very costly and error-prone process. Code quality issues, you got no tests, so you can't refactor. The data as well, you have data here during an offline analysis, but in real time or actually in production, as your food panda orders are coming in, you're getting data from the live transactional database, which may not be able to serve this model's analytical workloads. So, the whole thing can kind of just run to the ground and just fail. We can't productionize it, or even if we can, it was a very pretty painful experience, or can be painful. And then anyway, we do what we do. We solve problems. We set up ML systems, that feature stores, CI/CD pipelines, this and that. And now this thing is in production. And we're all happy. We've got ML in production, and maybe your boss or somebody comes and asks, like, hey, I know this model that we deployed last month is 91% accurate on the holdout set, but how many wrong predictions did they make in production last month? What's the average accuracy, right? In the last week. So these are pretty hard questions. If you feel uncomfortable listening to these questions, because they are uncomfortable questions, it's very hard to answer unless we have kind of instrumented and done the right, have the right architecture to support online evaluation and things like that. So that's the usual story. And if you've tried this before, you probably can relate. If you haven't tried it before, you may relate in the future in one day. But taking a step back, this is not an anecdote. In fact, many organizations have played this game. And in 2019, 87% of players lost this game. So they tried to productionize, proof of concept, but only 13% actually succeeded. And out of those 13% that succeeded, in 2020, more than 58% take more than a month to deploy a new model. And recently, State of Enterprise ML published a new statistic, and now it's 64. So more and more people are finding it hard and rather longer to deploy a model. It takes more than a month. And behind this 1 month number is not just a number. It's actually a data scientist toiling behind the scenes in trying to, release a thing. Rather than doing data science, you're caught up in your, release process, manual testing, whatever that is. So the sense I've got working with several data scientists is that data science was once upon a time like the sexiest job of the 21st century, but the job description does not match the on-the-ground reality. There's a lot of toil, there's a lot of manual work, there's dissatisfaction, burnout, turnover. So the next question is then, how can we avoid these pitfalls and thrive in this process? And that's where this whole idea of effective ML and continuous delivery comes in. So from a few past projects that I've been on, again and again, I'm learning and seeing that ML is not enough. So to effectively deliver ML products, we need 4 cross-disciplinary capabilities. Number 1, software engineering. So, your automated testing, learning how to use your IDE to write code effectively rather than coding in the blind, or rather coding without the IDE's help. Code design, how do you refactor? How do you containerize things? So these are typically software engineering capabilities. And then machine learning itself, right? So how instrumenting your evaluation, your CI/CD, data quality, MLOps, which we'll touch on later. And then more importantly is lean delivery, like building the right thing. So we'll again go to all these things in detail, but I just want to at this point call out that it's a kind of not just ML. It takes a few other skills to kind of do this successfully. So this is a slide that we'll come back to and again and again. So ML Ops, CD for ML. It's about bringing together engineering, product thinking, lean delivery to focus on great outcomes. So I really am trying to improve this visualization, but the whole thing is like we all, and if you're in a tech company or business organization, you are concerned with the why, right? You want to have happy customers, you want to meet your revenue targets, you want to have happy internal team members as well. You don't want people to burn out, you want people to come to work, enjoy work, things like that. And the thing that contributes to that is delivery flow. Every day you come to your work, you write code, you ship code, you're happy, releases are stress-free. So the flow and the cadence of that contributes to that. Features going out faster without defects. People are happy internally and externally. And also product quality, right? Not an afterthought, not a thing you test in production, but a thing you test before going to production. And we've gone through a list of kind of sensible default practices we take to our teams and try to abstract them into some categories. So at the center part is the kind of principles, and on the outside is categories of practices. So we see that, fast feedback, probably I won't go into too much detail now. We'll go into detail later. But yeah, this is kind of the whole why we care about, automated testing or containers. Like, these sound abstract and engineering focused, and it's like, why is David telling me to containerize my code? It's all about improving your flow to, improve the outcomes. So today's kind of rough outline, we've talked a bit about this already. So what is the cost of not doing ML Ops or CD for ML, continuous delivery? We'll clarify a bit of jargon. There's a lot of new words, so let's understand what that is. And then we'll iterate through 4 principles and supporting practices. And then we'll have Q&A and a hands-on exercise later. But I did start the talk saying I don't want to just throw information at you. So now I want to pause and also ask you if you want to put it on the chat or come off mute and just share. Is there any other questions about ML Ops or ML that you also want to know, rather in addition to what I've just mentioned? Maybe let's take a minute to think about that.
What's the purpose of using containers when it comes to ML? Because I thought, like, traditionally containers are used for application, and you need to put them in maybe a container service like AWS, ECS, EKS.
Yeah,
how the model containers?
Yeah, that's a fantastic question. We will probably go in detail in a bit, but right now, the short answer is, in application world, we are containerizing what we are deploying, right, as a web service, a UI. In machine learning, what we're deploying is a runnable. It is a training job that may run on a cloud instance. So that is a fresh box. There's nothing about that. There's no PyTorch, there's no TensorFlow. So containers help you to specify that and shift left to have production-like environment. So what I'm developing now is the exact thing that will run in that GPU instance or whatever that is in the cloud. So that's the short answer to that. Cool. So other questions? Yes, what is MLOps? We'll get to that in one slide. I want to know what is the entire process example, like data pipeline, ELT to deployment. Fantastic. So we will talk about that. What are the things used and how do we pick up such skills? So we'll probably come back to skills at the end. But yeah, we'll talk about what the process looks like. Cool. Yep. I'll continue, but feel free to add on questions in the chat. So let's answer Shang's question about what is MLOps. So MLOps learns or borrows a lot from DevOps. So just for park the MLOps for a moment, let's think about DevOps. So DevOps, history of it is that, maybe 10, 15 years ago, application developers used to just write code. And then we don't think about, there's no Kubernetes, there's no Docker. We don't think about how we're going to deploy this thing. We just write the code, it works locally, you throw it over the wall. It's now operations job, another department to go deploy this thing. And there's a story called the Phoenix Project. There's probably a book summary of that on YouTube somewhere. It talks about how this is so painful, like the people getting up at 2 a.m. to fight fires, deployment release, like supposed to deploy on Thursday, but then deployment failed on Friday, you got to come to work on Saturday to fix this thing. So DevOps is saying like, hey, let's break this wall. Let's forget that. Let's have developers write infrastructure code, like your containers, your Kubernetes, whatever, and have your operations folks also write code, like using infrastructure as code, again, Kubernetes, Docker, whatever tools you're using. And most importantly, DevOps is not just tools and technologies, right? DevOps is a culture. Primarily, DevOps is a culture. It's about breaking down this wall so that we come together to build great products, And then in terms of techniques and tools, we talk about monitoring, we talk about CI/CD, actually not CI/CD strictly speaking. We talk about infrastructure as code. There are tools to support DevOps, but fundamentally it's about breaking down this wall. So coming back to MLOps, like we still see this today. I think quite common to have like a data science team somewhere. You train your amazing, awesome model, and then a few weeks or months later, you throw it over to say, hey, now productionize this thing. So I think there's a lot we can learn here from DevOps world. And I've seen this before in my past projects where we create these cross-functional teams where we collaborate, like production from week one type of thing. That helps a lot. So we will go into more detail, but roughly speaking, this is the cultural aspect of DevOps, MLOps. So again, to Shang's question about MLOps specifically. So when we talk about DevOps engineer, you typically think of tools, right? You think about your container hosting, talk about containerization monitoring. So similarly in MLOps world, we talk about, this is a kind of a canonical or prototypical MLOps stack. Like at the core of it, you got ML pipeline, which we're very good at, as data scientists, ML engineers. We know how to run code to train the model, but there's kind of peripheral or actually essential things around training. Like when you do train something, you want to track your experiments. You want to collect your metadata, like say, I trained this model with this data and I got a 72% accuracy. All of those things you want to track that, collect the metadata in the artifact store so that you can have reproducible experiments. And then every model you train, they are production release candidates, right? So you want to track them in a model registry, just like how you have your Docker registry, right? Every commit triggers a build that eventually recreates a release candidate that is in your Docker registry that you can eventually deploy. So that's kind of these components around there. So there's also feature store, experiment tracking. So I know I'm putting even more jargon on the table, but in terms of what MLOps is, from a cultural perspective, it is that. And from a text perspective, it's about kind of thinking about, for my organization and problem solving, how can I bring these components, and later on we'll talk about the value of each component. For example, feature store, what's the value of that? Cool. So that's MLOps. That's the first jargon. The second jargon is jargon. I mean, just trying to be funny. Continuous delivery, right? So continuous delivery is again a software engineering practice. Started maybe 10, 15 years ago. So the idea is simple. Automate as much as you can. Build quality in. Don't do testing at the end as an afterthought in production. Don't even do the testing in staging or pre-production manually. Build that quality into your development process, right? Your test is part of your code, having an integration test, your test pyramid, all of those things. So you build quality in, you shift that left. Another thing is deploy frequent, early and often. So rather than building this thing for 2 months and then trying to develop this, rather deploy this, 200 commits. We know how that ends. Typically it fails. So how do we reduce that risk? Every commit, every push, you train your model, you do your thing, you run your tests, you deploy it pre-prod, and then you run your post-deployment tests. If it passed, go to prod. So every change set, you just exercise this pipeline, and that reduces the risk of things. And also everything is in paper, not paper, but it's everything is Git commits and artifacted, so it's auditable, it's repeatable. How do we manage artifacts in CD? So yeah, we'll talk about that later in a bit, but yeah, there's absolutely a artifacting component of it, and we'll deep dive there. So CD for ML is about taking what we just described here and applying it in ML. I won't go through this very wordy that slide, but we will kind of walk through the process of implementing CD in machine learning projects. Cool. So let's dive into the first principle of effective ML and then the supporting practices. And this part I probably like make it less formal and just kind of have more conversational style, because it's a lot of theory and information, but I do want to share these because I think in Thoughtworks, we do a lot of this agile engineering. So we want to just share that across more widely. So first principle is shorten feedback loops. And the question is, are feedback loops as short as can be? So let's switch gears out of tech for a moment. Just think about users, right? So typically ML products, we tend to, I think, not always, but we tend to want to build a good product, a perfect product. It may take weeks, it may take months, or even a year. We say, okay, this model is accurate enough, or its production is nice enough. Then we show it to the users. And then when we do show it to the users, it's like, okay, it's not a great UX, quality is bad, or UX is bad, or in this maybe use case, users cannot tolerate the non-determinism of machine learning. So how do we shorten that feedback? And simple answer is user testing, right? So before trying to build the thing right, we make sure we build the right thing. So we do user testing, like ask user, do you like red, green, or blue? And then for user testing, we find, okay, you like blue. So let's say blue is like a chatbot or something. Okay, let's develop this thing. We've tested it, we validated it. We uncovered risks or cases where ML might not work early on. So it's not so much the outcome, but also the process of understanding the problem space with the users. So user testing is one really simple and effective way to shorten the feedback loop. And then from automated testing, I think for folks who have worked with ML, that it's not common to write tests. And in Jupyter Notebooks, the way we know if something works is we make a line of code change, we restart and run the whole notebook. And at the end, we see maybe, okay, is my print statement still saying 72%? Or did it say 73.1% before? So it's all pretty like non-automated. So later on in the hands-on example, we'll show you that you can actually automate a lot of these tests. You make a change, you run a command, literally within a minute, you will know if everything is working or not. So, that is another way to shorten feedback loops. And then from a team perspective, a long feedback loop would be, you find out a colleague is not happy with the culture or the work we're doing when they leave, right? In the exit interview, they're saying, oh, I'm doing too much non-data science work, or I'm, doing too much ad hoc, deployments, whatever. So if we had a safe team retro, team psychological safety, then we would have had the feedback within 2 weeks. We're safe to share the feedback within the team to say, hey, deployment kind of sucks. Like, can we improve that? Can we make it better for ourselves? So shortening not from your exit interview, but within, let's say, even 2 weeks or 4 weeks. So coming back to this rubric of practices or categories, we won't go into all the detail. I just want to maybe give you a quick flavor of what are the practices that support fast feedback. So in terms of ways of working, we talk about vertically sliced work. So I think later on we'll talk about vertical thin slicing. Maybe that's okay. What should we call out here? We talked about automated testing, which we'll see in practice later. From a data perspective, data can be tested as well. So rather than waiting for a 3-hour ML job to say, okay, finish your 3-hour training job and then fail because model was like 71% accurate, can we test that, have the in-loop tests? If my data distribution is skewed towards one class, like fail the job now, okay, I got a data quality problem. So there are ways to kind of instrument that. ML engineering as well, like later on we'll talk about these ML quality tests. So rather than manually eyeballing the number 71.3, let's codify it as an automated test. You comment, you push, CI will tell you if it's passing or not, or your local development ID will tell you if it's passing or not. You don't have to manually rerun an entire notebook. And finally, with monitoring, I think we have a monitoring story later, so we'll come back to this. But monitoring is a way to find out issues before your user calls you or makes complaints or even unsubscribe. So you find out what the issue is, you fix that even before it impacts users more widely. Also, because I'm thirsty, is there any questions anyone has at this point? No, all good. Okay. So next one is about build quality in. So these are 3 common pain points that I've experienced doing data science and also working with data scientists. So in machine learning, we typically want to know a few things about our models. Number 1 is this model that I just trained, is it better than the one that is in production? So that's the evaluation problem, right? And then second question is, how is this model doing in production? And so that's the monitoring problem. Like, is it giving really bad predictions? How do you close the loop on that? And third one is, this model produced prediction X. Why did it do that? And this is not just abstract theoretical questions. Sometimes I have worked with cases or clients where actually the customer calls and complain, or submits this email and say, hey, this model said this thing is Y, but I disagree, this is wrong. Like, your quality has some issues. So then data scientists are spending time debugging or resolving these issues. So then that's the explainability problem. Like the model predicted something for a reason. So can we explain that? And typically we answer these questions by manually prodding or poking our models, doing some ad hoc analysis. And in a mature team, these observable characteristics that we use to decide whether a model is of a good quality, whether it's good enough, all of these should be automated and discoverable with minimal manual intervention. So this is what it could look like. The state of your model against a holdout set or a new fresh data is 91% accurate. You can run offline evaluation to know, okay, it is 94%. And global metrics are also not enough. So there are tests called stratified tests or stratified tests to break them down by your key dimensions. Let's say gender or race, like maybe it's 94%, but can we break that down into the key subsegments that I care about? And second, about your monitoring. So every request is logged and monitored over time. And explainability, we've also architected systems where every prediction you can understand why you made that prediction. And typically these are things that data scientists already know how to do in an ad hoc manner. Like for this one, ML folks will know how to use Slime or Shep, or even just your coefficients in a small model. You can explain why the model said this picture is a cat, right? Okay, this part of the picture describes this as cat. Or tumor, whatever that is. So the next step is then, okay, this ad hoc intuition or heuristics that we have as data scientists, the next step is to instrument that and make that, not so ad hoc and manual. You can host a, dashboard or service that can do this. Anybody, non-tech people can come and find out why a model produced a certain prediction and can answer customer queries. You don't need a data scientist to, drop everything to come and answer the question. So coming back to build quality in, these blue teal boxes are your quality gates. So let's see how this looks like in the software world, and then I'll map it into the model world, ML world. So the action here is that we make a code change in the software thing, right? I change my line of code to make my button from red to green, right? So we push, and all of these things we will run locally as well, but here we push, and if it fails, we get fast feedback within seconds or minutes that something's wrong. I need to go look into that. And if that passes, you run your contract tests, like the external dependencies on my green button, if there's such a dependency, or there's a button, color of a button is hard to test, and trivial. It could be an API or whatever that is. You run all your suite of tests, and if it's good enough, then you're good to go to pre-production. You don't need any manual intervention. And in the past project, when we've gone to pre-production, we ran post-deployment tests. We say, okay, my service or my app, I have these assumptions or assertions that I want to run against my API. And if all of these tests pass, that means the API is doing what the external world assumes that it will do and expects it to do. And at that point, if it passes, then there's, for us, no more manual testing needed. So we just go to production. And after doing that, we have proactive monitoring. And if any alerts, anything, we get fast feedback to know, that like, hey, this user encountered this edge case with the green button, whatever that is, or this API response. Let's look into that. So all of that is your quality gates and fast feedback. In the ML space, so not only the code can change, the data can change. You might have new training data for this month or this week. And regardless of the change, you run the same things, right? The tests still pass, your model training test. So sometimes the training can take 6 hours, 12 hours. We have done it before where we run the same exact data pipeline or ML training pipeline with like 10 samples, a very small data set, and a 6-hour training job finishes in 2 minutes. And we say, okay, end to end, this thing doesn't blow up, the smoke test pass. Then we are confident we can train it at scale rather than wait 11 hours and then just have to have the last step fail. So that gives us, again, fast feedback. And same thing, contract tests. When at this point, we're like, okay, everything is good to go for full training. And after full training is finished, we run our model quality tests, the things that we talked about just now about stratified tests, your accuracy tests, things like that. And you can also compare your models. And this is, I don't want to trivialize this topic. It's pretty deep, and there are books that I can recommend for this. But the kind of intro level idea is that you can, every model you train, you can know which one is better. That's essentially the idea. And you can deploy the best one. And then same thing, post-deployment tests, and then you have your monitoring behind the scenes. And the additional thing for ML is that when we deploy a thing, that's a very valuable thing. There are users actually out there that are interacting with your thing and saying, hey, your model's great, hey, your model sucks. Whatever that is, we instrument a way to collect what we call these natural labels so that we can close the loop back and have better data for next time. So this is an essential piece that many people often forget, but it's in machine learning, as you know, it's garbage in, garbage out. So by getting these better quality labels, you can improve the model. There's some callouts and caveats here about adversarial. I forgot what's the word, like people teaching a model the bad things intentionally. So they're kind of more nuanced architectural things that we need to consider. But that's not to say that it's the worst thing to do is not to do it at all. Another bad thing to do is to do it without the quality gates. But we need to think about how we collect better training data for next iteration of this thing. So I know that's a lot of information. So, but that's kind of real world to the question about what the process looks like. That's a flavor of it. So to build quality in testing is a big part of it. CI/CD. I often see teams like say, "Hey, we are doing CI/CD." Then I ask them, oh, "Okay, what's your test coverage?" Say, "Oh, we don't have any tests on the CI pipeline." So, okay, it's not really doing CI/CD if there's no tests. So it's kind of all together. We talked about closing the data collection loop. We talked about ML quality tests and monitoring. So it's all part of that quality process, automated so that you don't have to stress about releases. It's all automated and done for you. Like we do it, front load the automation and the effort so that we don't have to do so much manual work later on. So that's the whole idea of MLOps, CD for ML. Cool. At this point, any questions?
Yeah, so actually, I think the term is poisoning. Yeah.
Oh yeah, thank you for that. Yeah, that is correct. Yeah, model
Yeah.
poisoning. That's correct.
A few slides ago, you actually mentioned about you gave an example that okay, I know that the accuracy is 73%, and then now whenever I deploy it, I know that um, uh, that this will definitely be 73%. Oh, okay, 91 or 94 is good also. So even better. um, can you give an example, like of a project which you did? It doesn't need to be, yeah.
Yeah. So we will see a hands-on example shortly. But the short answer is that it is not different from your typical unit test, except that there's some design decisions, especially if the training is going to be quite long. Then you want to make sure that this test is kind of a decoupled pipeline, so that, you know, if let's say it fails because it's 72.9, it's like, okay, I want to change that code to 73, so lower the threshold a little bit, but you don't necessarily want to train the model 12 hours again.
Yeah.
So, but you know, that's not an issue if the model training takes like, you know, 5 minutes. But later on, we'll have a hands-on automated test that you can see what the test looks like.
Okay.
Ooh. I do feel I have shared a lot of jargon and very technical information, but I hope it's not overwhelming you. It's kind of a quick whirlwind tour of what MLOps and CD4ML looks like. Day to day in our own projects is the bread and butter that helps us be relaxed and stress-free when we are doing deployments. Like, for example, this kind of conceptual thing is actually a CI/CD pipeline that we used in the project. And then, you know, before we had this, releases were very nervous. We got production incidents and things like that. But when we set this up, then over time, piece by piece, deployment is no drama. You know, by the time we want to click this thing, we know that quality gate, CI pipeline, everything is green. We're confident and just go to production. And so it's kind of day to day what we do. In terms of technical details, when we do want to do this, yeah, I'm happy to have a chat for further detail. But I think for this session, just want to kind of keep it generally high level. So at this point, we're going to shift gears a little bit and talk about different set of principles and practices. So here, let's call out the importance of language, right? So when we say something is an ML problem, what comes to your mind? So you're kind of thinking about data, you're thinking about exploratory data analysis, you're thinking about balanced data sets or evaluation ML, right? But if we say that this is a product problem, then what other words come to your mind? So maybe you're thinking about user experience, what's, you know, product as a user, you know, have we done the user testing for this product? So that's why the next principle on lean, we focus on a set of practices that are about building the right thing. So if the first part is about building the thing right with the right engineering practices, then this part is about building the right thing. And both of them are equally important. You can't do one without the other. So, yep, as I mentioned, lean is about, you know, the discipline process, and we'll talk about what they are, to iterate towards us building the right product. So, you know, whatever that is, how can you build, measure, and learn? How can you test and learn? So that you iterate towards what users want and what's, you know, helping them solve problems. The first section, we already talked about how to build the thing right, all these agile practices. And so lean to me was a really big and fuzzy word. Let's break it down. So at the core of it is about building a thing, measuring how good it was or how effective that thing you built has been, and then kind of learning from that. Right. So we start with number one, and before we even build, first step is identify the value. So from the user's point of view, value is defined as what the customer is willing to pay for. And so we can do this using qualitative research, quantitative research, right? So let's say you're building a chatbot, like asking and going through that process of user testing. Okay, what is the value that this chatbot is going to solve? Okay, maybe it will reduce wait time by 30 minutes, or maybe it will, whatever that is, identify that value. Second is to map the value stream. So once we have identified the value of a chatbot, let's say, the next step is to map down the current steps that the teams go through to build this chatbot. So maybe this whole value stream exercise is incredibly valuable. It's a whole talk on its own. There are probably talks on YouTube or on the internet you can check out. But this is a really useful exercise in finding out where the bottlenecks are. So in building a chatbot, you might find, okay, first we need to get kind of a governance board clearance. So, that might even take 3 weeks or 3 months, 6 months before you can, do the thing. So, or maybe forget governance. Governance is important. I'm not saying it's not important. Just to lay out all the steps. Maybe you find that you build the thing and then you got to throw your data science model across the wall to your API engineers. And in the past, we've seen maybe this takes, 4 weeks, whatever that time is. So map out from your historical experience what that is, and then identify bottlenecks, and then try to create flow. Like, so maybe this handoff between data science and engineering is the bottleneck. How do we create flow? Okay, let's create a cross-functional team, that particularly sliced team, so that we are from day one pair programming engineers together with data scientists to build this chatbot, and not having that wait about handoff time. The next thing is establish pool. So the idea is that you pool cards into development based on an established user need. So not just push cards into production or into your workflow based on what I like to do. So it has to be kind of quite disciplined about that. And finally, there's no perfect software, there's no perfect process. So as a team, looking inwards, how can we learn from the last iteration, and then kind of continuous improvement and keep iterating on that. I'll probably skip through these 2 slides. I think they're a bit kind of conceptual. But the key thing in your team, if you're doing MLOps, doing ML, just to ask a simple but pretty powerful question in that: how have we delivered value in this iteration? And usually sometimes I ask myself and I kind of can't answer the question. Sometimes, we get so caught up in story points and things, and, so it just, yeah. And it applies also outside of ML, even if you're not doing ML. So finally, the final principle for effective ML is prioritizing safety. So in our line of work, we may not lose a finger or an arm to heavy machinery, but there are still plenty of ways that we can compromise our own safety and the safety of users. So from a harm to self perspective, I'm sure you've heard of stories of like a code change suddenly bring down production server, like Instagram is down, loss of revenue, loss of trust. And this actually are quantifiable, right? Maybe millions of dollars lost or hundreds of thousands. So production defects happen because the quality gates in the pipeline are not strong enough. So in this case, like maybe for ML, there's a lot of ad hoc, feedback loops. Maybe the defect is there, but we just didn't catch it. And then we push, and then we wait for a PR, some senior engineer to say, okay, yeah, it looks good to me, for like a, 300-line code change. Like nobody can ever reason about that to find a defect. You've got to test the thing through your CI quality gates or your manual testing. And then, anyway, we miss the bug, it goes out, the harm is done. Not just to the users, but also to the engineer, right? The stressful kind of post-mortem that you might have. So what could good look like, right? All of these quality gates. Let's say I know that this defect could be there. Maybe it's happened before. If it's happened before, we write a test for that. And then we write that test as part of the bug fix, and we fixed it before. So now moving forward, if that should ever happen again, we push, and then CI will stop us to say, hey, you've got a bug there. Oh, okay, fine. Thanks, CI. I will fix that, and then push, and then go ahead. So that's the engineering safety. But and let's turn outwards now to look at the safety of users. So you don't have to look very hard to see the unethical consequences of ML models. So the stories and actual cases of predictive policing algorithm reinforcing racial biases in policing data. So models learn from data. If the data is biased, and the model is going to be biased, right? Garbage in, garbage out. Amazon's recruiting tool showing bias against women. Again, the data had a lot of men, and in this story and analysis, the people who analyzed it found that the model actually penalized CVs with the word women. Like even if it's just like I joined a women's hockey team or women's debate team, like those CVs were not recommended in that recruiting tool. Thankfully, they shut it down within a year. But yeah, it's like a indication of what could happen if we don't test for these dimensions of safety. So there is a pretty great resource that I'll share with Toshao that we can share after, called the Responsible Tech Playbook. So there are a set of exercises you can take to test from an ethical dimension, like what kind of impact or unintended consequence or harm that the ML product, and generally this is not for ML, but more generally for any kind of tech product. We can even look about data ethics, like are we using PII, or have we got user consent, things like that. So have a look, and if you are building a product, you can think about running a short workshop, can be just 2 hours, to see if you can uncover risks about your ML model before it comes up in the newspapers. Cool. So safety is comes on top of a lot of the agile engineering practices we talked about, but at the same time, there's also that kind of qualitative dimension that we need to be able to kind of raise our voice and say, hey, I don't think this model is really doing what a fair thing, or like we shouldn't be using this data, or there's a certain bias. We also need to advocate and call out for that. So takeaways. This has been a whirlwind tour of what MLOps is, what CI/CD looks like in an ML context. Later on, we'll have a hands-on exercise where I will show you like automated testing, refactoring, things like that. But I think the main story here is that in the past, maybe 3 to 4 years, Thoughtworks, I think we're software engineers, DevOps engineers. We come from the background, and data has come along, AI has come along, and we found that actually it works really well together. A lot of what we're doing in the DevOps world maps nicely into ML. A lot of CI/CD stuff kind of maps nicely. So it is kind of bringing the best of both together. Like it's not just sufficient to test from software perspective. There are model ML specific quality tests that you can't test, before the model is trained. So, it's about taking the best of both together. And yeah, focusing, and these practices are not for engineering's sake, but more like we have tried this and it has helped us, improve our flow, catch defects, prevent, instead of spending time on production incidents, we catch defects before they go out. Team members are happier. You don't need to do, painful releases. Don't have to do bug fixes. I mean, there's still bugs for sure, but not as much as you would have if you didn't test for those things. And yeah, so these are the kind of practices that helped us to that end. So Q&A. Any thoughts or questions or comments from anyone? Oh, there's a question there about neural network model tests for CI/CD. That's a really good one. So I can talk to that, but I also want to give some space for folks to ask any other questions as well.
David, there was a question earlier before Shang. So he or she was asking, she wants to know about the entire process example, like the data pipeline, ELT, etc., to deployment? What are the things used and how do we pick up such skills?
Yep, that's a great one. So thanks, G, for the question. So end-to-end process, some of the details are abstracted away or not put here. My personal process, this is not just on CI. So these are things I would run at least partially locally. So as I'm developing and make a code change, I will run a command, run the unit test, and we will see this in action later. I will run a training smoke test in 2 minutes, know everything works. What's not shown here is probably the model training architecture. So here we will ingest data or pull data from our feature store. So our training set pulling here. So we had our data was in BigQuery, and we had kind of SQL interface for us to write our SQL statement in code, bring the data into there, and then do your, train test split, your feature engineering, and all of that in code. So that's generally that. So, and before that data gets into the data warehouse, there's also work that needs to be done to get the features from your operational systems into your analytical systems. So yeah, this is just a general view of things. Does that answer your question, G? I'll take that as a yes. Otherwise, you have to hear me ramble on. Yes, Brian.
Yeah. So, what does it take for someone in DevOps to move towards MLOps? Because you said that DevOps is quite similar to MLOps, and just thinking, since CI/CD is kind of similar to ML as well, Ops as well. Does MLOps also deal with infrastructure side? What are like the requirements usually for an MLOps?
Yeah, that's a great question. So I think there's a nice overlap. So certainly your DevOps skills in terms of deployments, infrastructure as code, your cloud providers, AWS, GCP, Azure, whatever that is, they'll be useful. Laying on top the ML engineering side. So there's it's like still moving very fast, but pretty mature in terms of like the just wealth of resources to get into ML engineering. I will refer us to this course that has a really nice, it's called Made with ML. It's open source and it's free. And this person is just awesome. Like, he's written a lot of short tutorials on not just ML itself, but also ML ops, like what you need to do in terms of testing the model, tracking the experiments, the deployment side of things. So yeah, I can share that link right now and also maybe after the call. I can see G has a question as well. So iterate on my earlier question. What are the tools used in the various process like Jenkins or CML? Okay, so this is a really fun question because there's a lot of tools. I'm trying to recall what is MAD, I think they call it MAD. State of ML. So there's like this ML landscape and it's just like so much going on. The long story short is that focus on the abstractions, focus on like, okay, what do I need to do here? Okay, I need a model registry. And then there's probably like 10 or more technologies that you can use. But to answer your question, this is the kind of canonical, typical things that we will use in MLOps. And then for each technology, there will be a lot of like tools that we could use. So for example, just trying to find one for AI, MLOps infra. So for example, just here, just infra itself, you can train with MLflow, you can train with Selden, yes, Neptune AI. So there's a lot, and I would encourage us not to get overwhelmed. I feel very overwhelmed when I see this kind of, awesome ML type of list of like really big things. Yeah, focus on the abstraction. Like, okay, I need CI/CD, whether you use Jenkins, Bamboo, build kite, whatever that is, like it doesn't matter as long as you're doing the right practices. Yeah. Oh, thank you, Tosha. Yeah. Cool. So maybe I would pause for 10 seconds to see if there's any last questions before the hands-on.
I do have a last question here. For someone who is not really very familiar with MLOps, are there any courses or any resources that you'd recommend that we can get started with?
Yeah, that's a really good question. I'm just jogging my memory. MLOps. I think apart from the Made with ML, there is another channel called MLOps Community, which has a kind of like a lean coffee style chat. And somewhere in there, there's probably like an intro to ML journey type of thing. Yeah, I did say we will be informal, and yeah, so end-to-end MLOps basics. Looks like some fair number of views, so using Docker. So yeah, this is not the only one. The problem I think is that there's too much. It's so overwhelming. But yeah, I think those two are probably good starting points, and you may come across more with through your interactions.
Thanks, David. G has one more question.
Oh,
Based
yes.
on the MLOps stack template, are all processes automated, tracked?
Yep, that's a great question, G. So definitely. So each component that we deploy, let's say if it's an experiment tracking service with ML flow, like we would be automating the deployment. Everything that all the sensible defaults that we take from engineering, like infrastructure as code, no click ops, auto scaling if scale is a problem, those we will apply accordingly. Yeah, it is too much to learn everything. I absolutely agree. After maybe 3 years of doing ML engineering, I still feel overwhelmed. It's a lot. And what are the most common ones? I would say probably start with the fundamentals, and it's kind of like climbing a ladder. You got to put one foot up in terms of understanding theoretically, then you got to put one foot up to try in a hands-on project, which is hard if it's not in the day-to-day job. But yeah, it's really hard to kind of digest and say, okay, I know everything about MLOps there is to know, and let me do that now. There's like kind of, I don't know, 100 steps on the left foot. But yeah, I think just make it fun for yourself, or make it as you read, and if you have a hands-on code that you can try, do try that out. Sorry, I'm just getting a bit of brain fog after talking for 1 hour 10 minutes. But yeah, don't be overwhelmed. Take it a step at a time and learn it just like how you learn anything, whether it's a Python or Docker or JavaScript or CSS, whatever it is that you learn, kind of learn by doing. If you can do on the job, that's great. If you can pair with engineers. So, and a lot of this should be an ecosystem or like a team thing. Like when you join a team, you hopefully would have that kind of team of ML engineer or folks who have some experience. Then just learn from pairing. In a mature company, like if they have done ML for a while, then that will be there. The kind of support and sensible default guidelines. You don't have to go to a company and kind of try to do everything yourself. It's kind of a team level thing, and that's why my upcoming book is called Effective ML Teams. Is all of these things, like nobody can write tests, and even if one person gets so good at it, it needs to be a team effort to have the baseline. Last question. Any advice on building portfolio project on MLOps? Yeah, that's a good question. I think the thing with portfolio projects is, and it's why ML is so accessible, it is that you can run a notebook, see a chart or see a 99% accurate model, kind of have a screenshot, and there's a shippable artifact. Right? That's something I personally can post or share with my colleagues and be like, yay, I train a self-driving car. So with MLOps side, it's more backend. So I would maybe think like how I would learn Kubernetes or how I would learn any DevOps technology, which is not easy. Typically, I follow like a structured, like, introduction to the Kubernetes course or intro to Docker course, and just kind of follow along. And if they have a capstone project, try it out. So with MLOps, there is a really great book called Effective Data Science Infrastructure. So if you have a company book budget, this is a good one. It talks about Metaflow, which is a tool I've used before and works really great for scalable, elastic compute and things like that. So yeah, there'll be capstone projects like an infrastructure you can spin up. So that's one way to structure the project. In terms of portfolio, it's not like so showcaseable as off the top of my head because it's quite backend systems, but you still can call it out, in your resume to say, I have experience with this and that in MLOps. Cool. So let's switch gears and talk about hands-on. I think we have maybe just 15 minutes or so. So this is supposed to wake you up if you're sleeping. So more hands-on, more interactive. It's like, imagine you are pairing with me on a project, like with you and me together, we have this Jupyter notebook that is like, all the panes of Jupyter notebooks. I'll show you what that looks like. So the context is that this is a credit score prediction model that I got off Kaggle. It takes some data, customer ID, month, name, features, occupation, income, and then it has your target about credit score, good, poor, standard. So it's multi-class classification problem. And this notebook has a couple of problems. It's useful, like in terms of exploratory data analysis, like we get insights into, there's a skew in the data. We learn about missing values. We learn about the distribution, outliers, things like that. So these are great and important during the exploratory data analysis, but it becomes very hard to maintain and test this code. If I were to have a typo here, like letter I, if I accidentally remove it, nobody will ever find out unless I rerun the entire notebook, right? And so it's hard to maintain, hard to read. Finally, the output of that is that, okay, we've got sorry, I just go too fast. Finally, we train a series of models. Let's say this is the gradient boosted model. This, okay, to know what this is. We've got ADA boost, random forest classifier, and you instantiate this guy. I can maybe to make it accessible, makes it all clear. You instantiate model, you fit it, you evaluate it, and then you get some scores about it. And then finally, he sticks it into a data frame and say, these are all my models, forest, and these are all my training test scores. So this is our starting point. And then I typically use this process to refactor Jupyter notebooks. Number one is to make sure it works. Run it from start to bottom, make sure nothing blows up. So we saw that, okay, this works. It trains the models, got this baseline accuracy. Then we convert it to a Python file so that we can use the IDE to move things around, refactor, use the shortcuts. And the next thing I do generally is to remove unnecessary print statements. So this is harder than looks. So I kind of go through the code and say, okay, which is just noise that's really clouding out what I really need to see, what's the real behavior. For example, a lot of this is like, just pull up. Like a lot of plots and things which, they're good for data analysis, but not necessary for model training. And then the next thing I start to do is to list the code smells. And we don't have time to go in detail, but essentially this becomes our to-do list to say, okay, I've got a code smell here, like unreadable variable name or magic number, or for example here, code duplication. We can see that one of the code smell is that to train so many models, we have to repeat kind of the same code, right? You get the model, you fit, you score, you solve the same thing from the previous model. So maybe that's another code smell. And the next and most important thing to do is we write a characterization test, because without tests, refactoring is very dangerous. People will get hurt. You will pull out your hair, right? So without tests, we cannot refactor. So that's the first thing we do. We add the characterization test, and then we go to the cycle. We add the test, we get the test pass, we extract the chunk of code into a module, we commit it, make small commits along the way, and we kind of iterate. So let's see that in action. So this is called credit score prediction. Small font size. So I use PyCharm. I highly recommend it. It's very nice. A lot of refactoring shortcuts just kind of work out of the box. You have an intelligent assistant coder. So here at this point, I've done the first few steps. So I made it into a Python file. I removed some of the noise. I haven't listed the code smells, but the first thing we're going to do here is to add the print, the test. But we can roughly know some code smells here. Like, you know, one code smell is like, there's no abstractions, meaning like the story I tell people usually is like, if I go to a restaurant and you open a menu and the first thing you see is like, okay, add some oil, chop some onions, add some garlic, brown the garlic. That's all implementation details, right? There's no abstraction to tell you actually. It's better if you open the menu and say, okay, this is onion soup. So that's the beauty of functional abstractions. You can just read the function. You don't need to spend all these cognitive resources to understand how it's doing things. You just need to read the function. So that's the main code smell we're going to target. And so, yeah, go ahead.
Are you sharing another window as well?
Oh, yeah, I'm sorry. I was showing my browser. Yeah, thank you for that. Sorry, yeah, so this is the menu thing I was talking about. Like, there's so much implementation detail. It's telling me to chop onion and fry garlic and whatever. It's like, I don't care, just tell me, okay. For example, tell me that, oh, sorry. For example, just tell me I'm going to use a shortcut to say extract method. So train model. Let's say, I'm just writing pseudocode like you could now. Instead of having to understand that, I can just see, oh, okay, this is training the model. And this is a really bad and big function still, but I just want to show you like, okay, it's better to read the title name onion soup than to read the whole damn recipe about onion soup. Cool, so let's start. So we can't refactor without tests, so let's start by adding a test. So this should answer an earlier question about how do we actually write an ML test. So it's not different to your Python unit tests as a first pass, as a start. So let's create a Python test called test model training. So we write, for folks who are new to unit testing, so this is a typical unit testing structure. And as you can see, like I'm just going to type enter now. The IDE helps you import the right things. I don't have to get lost in the implementation detail of how do I import this thing. So we say test, usually we say like the function name. So like train model trains a model with metric above threshold. So specify threshold. I guess the font size will be small. So whoa. Okay, so in unit testing, there's the idea of arrange, act, assert. So we know that eventually we're going to call our function called this train model thing. And then at the end of it, I've simplified the different models, just one model this time. Maybe if we return the score from this function, then we can assert on the score that is above a certain threshold as a start. It's not a perfect test, but it's a good starting point. And this is what Martin Fowler in the book called Refactoring saying that we need to first draw the seams of refactoring. We need to draw S seam. We need to draw around what we can refactor. So this code is literally not testable because there is no seam around it. So let's draw that first seam. Say I will draw a box around here to say, all right, this is called train model. And this, again, the seam is not complete yet. This function needs to return something. And let's say it is the score. And now this is testable, right? I can call my function called train model. And my IDE, I don't know where this is from, but it will help me, option enter. It will help me import this function from the right place, the function we just defined. Let me just, I think that's okay. So now we know it returns a score. And this is actually the act, and we can assert that assert greater than equal to. And again, this is our IDE helping us, like assert equal AB, what should I put, like what comes with? Okay, fine, let's read the documentation in line. To say, I just press the shortcut F1, assert AB. So assert that A is bigger than B. Okay, so I want to assert that A, which is my specified threshold. From the screenshot, it was like, anyway, let's just put like 0.5 as a threshold. We will put a specific threshold at the real model quality test, but this is more a smoke test. Okay, so we've got this thing. Should be able to start my container, which I had built prior to the workshop. And I will run my unit tests. And I just have a kind of utility script for that. Eight minutes left. So, so we train the model, we assert. And as you can see now, it's a little bit slow. And I eventually realized when I was preparing this workshop is that the fit transform was pretty costly and expensive. And this is still like faster feedback than running the whole notebook, but to me, it's still a little bit long. So what I'm going to do is to, instead of having this function like internalize this model, I want to pass in the data so that during test time, I can pass in like just 10 rows, and then you can exercise the whole code base and see that everything works. So, but do one thing at a time before I make a change. I want to see that, okay, I have a test to catch my changes are working. Let's wait maybe another probably 10 or 15 seconds. Okay, it failed. So 0.5 is not greater than okay, sorry, I got the order wrong, right? So score needs to be greater than my threshold. But I think that's enough for us to do the next step. So I want to move the data out and instead pass in the data here. And that's the data frame. And I don't know if you're a little bit annoyed by like all the squiggly lines and things like that. So I'm going to hit a shortcut and let the IDE just do some reformatting. Oh, sorry. And all these auto imports is still imports are really annoying. Like what's it doing? Not doing anything. So clean up the imports. Control Option O. Okay, so we've got data. Where's it squiggly? So this is the function. So when we call this function, we're going to pass in the data. And it's in the main method. So now we decouple the script. The training script, when I run, will actually load the full training data. And this may be coming from your data warehouse, feature store, whatever that is. It will pass it the real data. When I do run this script, Python src train, it's going to do that. But in the test, we decouple the data from that so that we can load whatever data we need. In this case, let's just say, okay, let's fix this first. Option enter, import this pandas for me. So that like the ID helped us with that. I didn't need to go type that. And let's just say I would just want the first 10 rows. Now, let's run the test again. See how much faster it was. That's the fast feedback we're talking about. There's a lot of warnings in the actual code, so we need to refactor and fix that. But now we have our safety harness in that no matter what I change, let's say I change a bunch of things, I decide that that's not needed. I run a test, I know, hey, oh crap, I introduced a defect. This credit mix was a string, and I did need to fit transform to get it into an integer or categorical variable. So, oh, okay, thanks test, you helped me. So let's like not make that bug. It's okay. Oh crap! What did I change there? That's interesting. Okay, so I guess maybe I clicked too fast before I load the right code. So with that test harness, you can really start. You can start to do that refactoring cycle. And 4 minutes left. So for example, let's say we have a bunch of, again, onion soup recipe out here that really don't need to read. Maybe I want to call this thing like MDF, right? So this thing happens for the first time here, and I can tell that because it's not highlighted before. So at this section, it's like I pass in the data and I get an MDF back. So why not abstract that as a function? So let's say we start here, draw a line here to say, I'm going to use the shortcut option Command M, abstract method called pre-process. And I made a change. Did that change break anything? Nope, all good. So the IDE did a couple of things. When I hit that shortcut, not only did it create that function, it knew that there was a dependency on MDF. I needed MDF in scope here. So it kind of, the IDE again helpfully did all that wiring fast. But sometimes it gets it wrong, but most of the time it's okay. Real quick, so what is happening here? Some value is here. Let's say modeling drop. Okay, so this is the train test split stuff. There's a date code here. Now IDE is helping us, like say, highlighting this yellow thing. What's happening? Problems. Statements seem to have no effect on line 24. Okay, very good. Remove it. There's date code. It's not doing anything. Date code. And actually, this guy's comments is helpfully telling us some boundaries around things, but okay, here probably split, and let's say this is called transform. You don't have to silver plate it. And you notice like I'm cleaning up the comments as we go, because your function, if it's a readable function name, then comments are actually a code smell in that I haven't expressed myself correctly or properly. That's why I need a comment to explain what I'm doing. If the function is readable, okay, pre-processed data, transform data for training, fit model, then all of this we can move into another place. Let's say I move it to training helpers, let's say. I want to move all these functions, helper functions, so that train.py is just focused on training. then you see the night and day difference. From a long notebook of a lot of things, you get a more maybe readable thing to say, okay, train.py, what are we doing? We load data, we train model. What is train model doing? You do some stuff here. You pre-process, you transform, you fit the model, you return a score. So that's the refactoring process. So with that, I think that's time.
Thank you so much, David. Can you please share your notebook or code with all of us? I mean, you can share, give it to me and I can put it on the recording. So we'll be uploading the recording on YouTube. So I'll put it in the YouTube description so that everyone can access it.
Fantastic. Thanks so much for organizing, Tosha.
Thank you so much for sharing your knowledge with us today, David. So I have just a small feedback form. So if we want to continue with more sessions, that will be, hold on, let me first share it. Okay. So if we want to continue with more sessions, please let us know how or what you want to learn, and we'll see if that can be incorporated. Okay. I hope you can see my screen.
Yeah, I see the QR code. Feel free to say no. There's no pressure.
I've also pasted the link in the chat. So it'll take only 2 minutes for the feedback form. And thank you so much, everyone, for attending today. I hope you learned something. If you have any questions for David, just feel free to unmute yourself and ask.
Yeah, thanks everyone. Yeah, thanks for listening through the session.
Thanks all.
All right, have a good one. So Shao, is there any other announcements you'd like to make?
No other announcements. If you guys are done with the feedback form, feel free to leave.
Okay.
Thank you so much, David. It was
No
really
worries,
great.
yeah. Thank you so much for organizing and for the opportunity to Shao. All right, have a great evening, you folks.
Thank you, guys.
All right, see ya.
Bye.